Hi, everybody. Josh Byerly here inside Mission Control Houston. I'm joined by my friend Camille Alleyne. How are you doing, Camille?
I'm great, thank you.
You know, all this week we're talking about, and actually all this month, more appropriately, we're talking about the anniversaries of Valentina Tereshkova, who
Hmm.
was the first female in space, and Sally Ride, who was the first American in space. One was 50 years ago, and one's 30 years
Hmm.
ago. Um, who more appropriate to talk about it than you? You know, your background is quite extensive whenever it comes to your education. You've got
Thank
a
you.
Bachelor of Science in Mechanical Engineering from Howard University, a
Hmm.
Master of Science in Mechanical Engineering from Florida A&M University,
Hmm.
Master of Science in Aerospace Engineering from University of Maryland, and a doctorate in Educational Leadership from University of Houston. So you've
Hmm.
had some schooling in science, which is
Absolutely.
pretty. But I think what's even cooler is she's actually a private pilot, which is amazing to me. But whenever you look at these anniversaries, you know, what does it mean to you, and what are kind of your thoughts on it?
I think in the last 30 to 50 years, we've made significant strides, and we've come a long way with the inclusion of women in
Right.
human spaceflight. To date, I think we've had about 57 women from diverse backgrounds, both cultural, social, different nationalities who
Yeah.
have flown in space. From American perspective, since Dr. Sally Ride, we've had the first African American woman, Dr. Mae Jemison, in 1992,
Yeah.
who flew. Our own Senate Director, Dr. Ellen Ochoa,
Hmm.
who's the first Hispanic American woman to fly in space in 1993, and then the first Asian American woman in Dr. Kalpana Chawla, who flew in 1997 for
Yeah.
the first time. We lost her in Colombia. But these women have really blazed a trail and inspired countless women who have come behind them and will for generations. From a global perspective, we've had this number of women who have flown in space from Japan, Canada, Europe, China, of course, Russia,
Yeah.
and we've had an Iranian American space tourist. So we've made significant strides, including women in human spaceflight.
You know, we try to always reach out to students and kids who are going into science. And whenever you take a look back at the school that you've gone
Hmm.
through, you know, what made you pick the courses that you took, and when did you know?
I was really good in math and science in my early years of schooling, and I had a passion for aeroplanes,
Hmm.
for airplanes and aviation. I also was very passionate about space from an early age. I grew up in the Caribbean, a small island nation of Trinidad and
Hmm.
Tobago, and I remember at the age of 6 and 7, sitting on the trunk of my dad's car many nights and just being awe-inspired by the vastness of space, not really knowing what that was all about, but being really mechanical and analytical in my thinking. When I decided that I was going to go to college, of course, I decided to study aeronautical engineering because of my passion for airplanes. Um, but then when I migrated to the States as a freshman, and I'm dating myself, the Challenger accident happened,
Yeah.
and that just changed my life. Like in those moments, I decided this is what I wanted to do. So I switched from aeronautical engineering to aerospace engineering, and you read my bio, so
Yeah.
the rest is history. I've spent 18-year career designing rockets and spacecraft systems, both
Yeah.
for Department of Defense and NASA.
So whenever you talk to boys and girls that are going into, you know, if they kind of have a hankering for science,
Hmm.
is that really the key? It's just for them to go with what interests them, what you know, what their passion is, rather than trying to say, okay, you know, the end of my career, I want to be here. Is it more important to say, well, here's what I really like to do, and is that the key?
Yes, it is the key. I think you have to follow the things that you're passionate about. Um, Specifically for girls, though, encouraging them to go into science requires exposure,
Hmm.
right? And so having opportunities as a high schooler to go and work in a lab alongside a professional scientist or researcher or engineer and getting that exposure and those opportunities to see what the real world of science and engineering is like has been shown to really sustain the interest of females continuing their careers in those areas.
So you work in the program science office,
I do.
you know, sort of the brain trust of all the science we've got going on board the orbiting laboratory. Whenever you take a look at it, you know, you were talking about all the different, you know, legendary females that we've had.
Hmm.
One of them just walked back in the room. Anna Fisher's over there as our
Wow.
count today. She's part of the original group of astronauts. But then
Hmm.
we've had dozens of astronauts that have flown up to the space station, females and males,
Mhm.
obviously. Peggy Whitson was a commander of the
Mhm.
space station back on expedition.
First woman commander.
Yeah, whenever you take a look at the space station itself, and a lot of these PIs, the principal investigators, are females
Mhm.
too, very diverse.
Mhm.
Whenever you look at the experiments, what do you think is probably the most promising thing that the space station offers for scientists and researchers, and all the things that are going on and what they're working on?
I think it's the amazing discoveries and breakthroughs that we have had and continue to have on the space station.
Yeah.
All the biological, chemical, and physical processes that are a function of our terrestrial environment is a function of the gravitational force, right? Our ecosystem functions because of that
Right.
gravitational force. And so when you take that variable out of the equation, then amazing things happen to those same processes, both in biology, chemistry, and physics. And so the space station really serves as a platform for us to do the investigations in those areas and see what those changes are
Yeah.
and have those discoveries and breakthroughs that we didn't know really could
Yeah.
happen or exist. And a perfect example of that is microbial virulence. When we flew the salmonella bacteria, and as a result of the microgravity environment, it became more virulent, or the disease causing potency increased. And so researchers also were able to identify the genetic pathway that
Hmm.
caused that virulence. And so they, as a result, potentially could develop vaccines for those bacteria causing diseases that will have an impact on our life here on Earth. Another one is after 40 or 50 years of human spaceflight, we recently discovered the vision degradation of
Nice. Yeah.
astronauts. And so just recently we started that investigation called Ocular Health, examining how that vision degrades during long duration space flights. And so all these investigations, in addition to the countermeasures that researchers develop as a result, will have significant impacts and benefits to improving the quality of our life here on Earth.
So last question is kind of a big one. Out of all the things we've done on the space station, what is your favorite experiment? You may have to explain what it is, but what's your favorite
I
experiment?
have two.
Okay, I'll give you two.
The first is AMS, the Alpha Magnetic
Okay.
Spectrometer, which is the largest particle physics detector in space. And up to date, it's been up there for almost 2 years, and
Yeah.
it's gotten over 16 billion hits of
Yeah.
cosmic rays.
There it is.
And so that instrument and the data we get from that instrument could answer the question of what is the origins of our universe. And from a physical and spiritual perspective, I think human beings are curious about that. How did we evolve? And so I think the results from that experiment and that investigation is really, really promising. The second one is Sally Ride EarthCam,
Yeah.
developed by Dr. Sally Ride, and it's one of the longest running investigations. It first started back in Expedition 2.
Yeah.
And what she facilitated was the opportunity for middle school students to be able to program the EarthCam camera that's on board the space station to take images of various geological features of our Earth and use that in their studies of science, of math, of pre engineering, geography, social studies, and history. And it's one of our global education programs. So we've been able to reach countless millions of students around the world just with that investigation. So that's really one of my favorites.
Well, even if Sally Ride would have never been the first American female in space, that is
A
that
huge
is quite a
contribution.
legacy
Yes,
to leave to students,
absolutely.
and they touch it, all the time. So
Absolutely.
I think that's probably one of my favorite ones too.
Yeah.
So thanks for joining us, Camille. Always
Thank you.
always good to talk to
Thanks
you.
to be
So
with you.
Camille Alleyne, if you would like to learn more about the office that Camille works in, which is the Program Science Office, and all the experiments that they help run on board the International Space Station, just log on to the NASA website at www.nasa.gov/station. Take a look at the left-hand side of the page under Research and Technology, and you can take a look at all the different experiments that the crews are working on every day. Thanks for joining us.
Thank you.